Hello everyone, my name is Parag and welcome back in my new video. In this video I'm going to teach you about the design of the retaining walls. Okay, so here what we have basically there are different two types of the retaining walls we have, right? The cantilever retaining wall, cantilever, okay, Cantilever, and second one is the counterfort retaining wall. I have I just draw both the diagrammatical representation of the cantilever retaining wall, and you can see over here the counterfort retaining wall also. Okay, so the cantilever and counterfort retaining wall, I have both retaining wall over here with us. So now basically we are going to start, like this video is all about only the cantilever retaining wall, like what are the basic things of the cantilever retaining wall I am going to teach you over here. So first thing is that why the cantilever retaining wall is used. Okay, now according to diagrammatical representation, if I give some comparison, in my second video I'll give some comparison with this counterfort retaining wall and cantilever retaining wall. But the first thing is that, like, what is the reason that only we can use the cantilever retaining wall, and what is the reason that we are going to use only counterfort retaining wall? The reason is first that you can use the cantilever retaining wall at height of only up to the 5.5 meter. Okay, if your height is up to the 5.5 meter, then and only then you can use the cantilever retaining wall. That means 5.5 meter and less than 5.5, we can see the less than 5.5 meter. If it is less than 5.5 meter, okay, then only in this condition, or less than or equals to 5.5 meter, then only you can use the cantilever retaining wall. Counterfort retaining wall you can use more than this. If the height is more than 5.5 meter, then that means if it is 5.6 meter, then you can go for the counterfort retaining wall. Okay, so these are the requirements. Less up to the 5.5 meter of the retaining wall, okay, you can use the cantilever retaining wall. If it is more than 5.5 meter, you need to go for the counterfort retaining wall. Okay, now coming toward this diagrammatical representation, let me tell you, it is a really very interesting topic. Actually I already uploaded some video, but I got some, because of some problem I not yet uploaded the part 2 video. Okay, so in I'll be placed my, because of my notes has been get disturbed, only because of that I am not able to upload the part number 2 of the retaining designing wall of the numericals. But now onward I am going to teach you. Okay, don't worry about this. Now first of all, we need to know about what are the general features of the retaining walls. Okay, there are different main types of the RCC retaining walls. These are the one cantilever retaining walls and the counterfort retaining wall. The cantilever retaining wall consists of stem, hill slab, toe slab. Okay, these three things are consist in the cantilever retaining wall. Okay, so first thing is that what the cantilever retaining wall is consisting of: the stem, STEM, which is this one. Okay, what you are seeing over here. Then second one is the toe slab. Okay, third one is what the hill slab. Okay, these three things are in the cantilever retaining wall. Okay, the retaining wall are used to retain the earth, fill or any other material, so the ground surface at the different elevations are maintained on either side of the retaining wall. The one of the main reason for the retaining wall is that the retaining wall are used to retain the earth, fill or any other material. Okay, from the name retain, okay, you can, it is simply tell that the retaining wall used to retain, okay, to retain the what the earth fill, retain the earth fill or any other material, Okay, so this is what exactly the main reason why we are using the retaining wall. Okay, now after that we are going to discuss about the cantilever retaining wall first. What are the wall proportions right now? So our topic number 1, like our part A, is that what are the wall proportions. Okay, we are going to discuss about the wall proportions over here. So now, first of all, the top width of the steam. The top width of the steam, top width of the steam. Okay, the top width of the steam we always consider as a 200 mm. Okay, we always assume it as a 200 mm. After that, the bottom width, second, the bottom width of steam. How we can get the bottom width of the steam? So according to bottom width of the steam, we get designed for a maximum bending moment due to the horizontal earth pressure, which is P. Okay, the bottom width of the steam we get, okay, as per the design, okay, designed for this means this bottom width of the steam is designed for maximum bending moment, maximum bending moment, maximum bending moment due to horizontal earth pressure. Okay, which is nothing but we call as a P, this one. Okay, now the width of the slab, okay, the width of the slab, third one is the width of the slab. The slab is given by, okay, the width of the slab is given by small b. Okay, the height of the retaining wall, this one, height of the retaining wall, which is nothing but given as capital H. Okay, now the width of the retaining wall, fifth, the width of the retaining wall is always how much, like we need to know about how much of the width of the retaining wall, the value of this retaining wall, how much. So width of the retaining wall is always 0.5 of the height of the retaining wall to 0.6 height of the retaining wall. Okay, for walls, okay, for walls without surcharge, yes, you okay, without surcharge. Now if there is any surcharge, okay, like any flow or whatever it is, okay, so then it may be 0.7 of H with surcharge. Okay, now after that there is a toe projection, like this one, toe projection. How much the toe projection we need, that the what is the distance between this point to this point, how much it is come front. So this distance is nothing but toe projection. So we are going to determine the toe projection. It is like toe projection is given by b by 3, like the width by 3. Okay, now usually the thickness for a base slab, like whatever the thickness for the base slab the given, like usually the thickness of base slab is equals to thickness of steam. Okay, whatever the thickness of steam we have, that is usually the thickness of the base slab. This equals to this. Okay, now you can see here, this is what intensity of pressure at the base. Okay, this is created only because of this retaining wall, because we need to manage the retaining wall over there. Okay, now what is the different things we have over here, we need to discuss right now. Okay, so like what are the hill slab, what is the toe slab, what are the check for the horizontal sliding, these things we need to learn over here. So I can simply tell you, like if it is not seeing to, I just show you, like this is thing what usually the thickness of the base slab equals thickness of steam, I just write over there. Now coming towards our the next point, like wait a minute, I just take my another page. Okay, okay. So now what are the, now we are here going to discuss the what are the design principles. Okay, design principles. My handwriting is somewhat different. Okay, you cannot simply understand, so try to figure it out. Okay, so now, so design principles are like, first is what? Hill slab. Okay, so what is hill slab exactly? The design for a maximum bending moment due to the earth pressure from bottom and weight of the earth and hill slab to the top. Like the hill slab is designed for a maximum bending moment. It is designed for a maximum bending moment. Okay, it is designed for a maximum bending moment due to what? Due to earth pressure. Okay, due to earth pressure from bottom and weight from bottom. Okay, from bottom and weight of the earth and hill slab from top. Not only the pressure from the bottom, we also design it for the weight of the earth, okay, weight of the earth and hill slab from top, and hill slab from top. Okay, so this is what about the hill slab. Now second one is what? We are going for a toe slab now. What is exactly a toe slab? Toe slab is nothing but it is designed for a maximum bending moment due to earth pressure from bottom and weight of the earth due to the same. Like it is the change is only that it is designed for a maximum bending moment due to that is same. Okay, designed for maximum bending moment due to the earth pressure from the bottom, weight of the earth, and not only hill slab but it is for the toe slab from top. Toe slab from top, that is one of the main changes. Like hill slab is designed for the hill slab with weight of the earth and pressure from the bottom. Toe slab is designed for the earth pressure from bottom, weight of the earth slab, and the toe slab from the top. Okay, now weight of the this one, all these things. Now, so weight of the earth on, sorry, it is not and, it is on. Okay, on toe slab. Now what are the checks? Now we need to check for the horizontal sliding also, like what is the horizontal sliding we have. Okay, so check for horizontal sliding. How we can get the check for horizontal sliding is like if the W is equals to total vertical load. Okay, so how it is total vertical load? We need to I need to show it to you. Okay, so it is like this. Okay, you can see over here, sorry, you can see here the W1, W2, okay, W3, these are the what the total vertical load. W1 is acting downward, W3 is acting downward, W2 is acting downward. W1 is a load of the steam, W3 is a load of the water, the earth fill over here, W2 is a weight of the slab. Okay, so we have to check for horizontal sliding. For that, the total capital W is nothing but the total of the vertical load. Okay, so you need to remember this thing because whenever we are going to solve the numerical, these things are really very important. Okay, now so here total vertical load equals to nothing but W1 because of the steam, W2 because of the slab, okay, and W3 because of what? The your earth fill. Okay, so this is what the W1 plus W2 plus W3. Now what is the mu and what is the P? As I told you, P is nothing but the horizontal earth pressure. Okay, horizontal earth pressure, okay, which is like this is your retaining wall. Okay, so here is the load is acting, which is nothing but P. Okay, and mu is nothing but coefficient of friction. The mu is nothing but called as a coefficient of friction. Okay, so these are the two things we need to remember. Now, what is the factor of safety against the sliding? That is one of the important parameter we need to know about that. Okay, the factor of safety against this sliding. I am really very sorry guys, because I am placing my video very after very long time. Okay, because of some time binding. Okay, so factor of safety, this is also important. Factor of safety against the sliding is given by mu into capital W divided by load, horizontal earth pressure, and this thing, that is this factor is must be greater than 1.5. If this condition is satisfied, then it is satisfied the factor of safety against the sliding. Okay, so this is what all about the cantilever retaining wall. Remember that whenever we can design cantilever retaining wall, only when we need our height is less than 5.5 meter or up to 5.5 meter only. Okay, beyond that we have to go for the counterfoot retaining wall. Cantilever retaining wall is very simple. If I wanted to give some brief about that for diagram, it is like this. Like here is what the diagrammatic representation. This is what the top of the steam we have. This is what the earth fill over here always. It is what it is called as a steam. Okay, this is the top of the steam. This is what the bottom of the steam. It is a toe slab. Okay, this is called as a toe projection. This is what called as a heel slab. This is what called a width B. Height from this point to ground surface, okay, of the top surface of the retaining wall. Okay, and this is what the intensity of pressure at base. How the intensity, like how much the load varying on the base, it is given by this intensity of the pressure, intensity of pressure at base. It is given by P1 and P2. P1 because of the toe slab, like the front weight, and P2 because of this next weight. Okay, so this is what the intensity given by the diagrammatic representation of the retaining wall. So this is what all about the retaining wall, guys. This is what a wall proportion we discuss over here. What are all the things we discuss? Okay, I think it may be helpful for you. So remember always one thing, like don't forget to subscribe my channel. Okay, and please visit my website, because I am going to upload some maximum spreadsheet on my website. Okay, not yet, I just upload only the rate analysis of PCC, but as soon as possible there's a lots of website, lots of spreadsheets coming for you. Whatever, when we learn this, after some days I'll also put the design of the retaining wall. You need to just put the input. That input only give you output within the limited seconds of time. Okay, so I need some time, because we cannot deal with this factor very efficiently. Okay, so that is what, because of time there is lots of problem, but we will clarify it soon. So don't worry about this, but try to visit my website always, because I am going to upload maximum post about the civil engineering, maximum post about the different big structure of the civil engineering. Okay, now, so I think that you are familiar with the basic parameters of the cantilever retaining wall. Now in my next video, it is all about the counterfort retaining wall. This video will be published in English and Hindi, in both language, okay, in one day. So that means Indians people can understand, and this is English for all my friends. Okay, so thank you for being there for me always. If you have any problem in this video for the design of the retaining wall, basic terminology, steam, toes, hill slab, whatever it is, okay, if you have any problem regarding the check, sliding, anything, just make in the comment in my comment box. And if you don't have any problem, then make also one comment like, yes Parag, if you need whatever the extra thing you need. Okay, so please keep watching and keep learning, and have a nice day. Bye bye.